Welcome to This Explainer. Let's just dive right in, shall we? We are bombarded with a steady stream of technology acronyms every single day. But even if you know what these letters refer to on a surface level, taking a quick moment to decode the literal language behind them provides this absolutely fascinating blueprint for how our devices actually work. So today, we're decoding the language of computer specs, translating those everyday letters into a concrete understanding of the machines we rely on.
Look, whether you're comparing specs to buy a new laptop or just troubleshooting a random network drop, you're interacting with a shorthand: CPU, RAM, SSD, ISP. It is incredibly easy to treat these as just abstract labels on a box, right? But understanding the exact words behind this shorthand shifts you from being a passive user to someone who truly understands the architecture of the machine. It just completely clarifies the logic behind the technology.
Our source material hits the nail on the head here, noting that mastering computer acronyms is highly practical for navigating tech specs, troubleshooting devices, and understanding general computing. Basically, these acronyms are a highly practical secret code, and cracking that code makes you a vastly more empowered consumer. It gives you the confidence to know exactly what you're paying for when you upgrade a device, and the clarity to pinpoint exactly what's going wrong when a system fails.
Okay, here's our agenda for today's explainer. Section 1, cracking the tech code. 2, hardware and storage. 3, networking and the internet. 4, software and programming. 5, emerging tech. And finally, 6, expanding your tech vocabulary.
All right, Section 1, cracking the tech code. Let's talk about why these acronyms matter for you.
Moving right along to Section 2, hardware and storage, the physical components of your devices.
Let's start by looking at the two main brains of your computer, the CPU and the GPU. CPU stands for Central Processing Unit. The operative word here is central. Think of this as the general manager of your machine, handling the fundamental logic and all those central everyday tasks that keep the system running. Conversely, the GPU is the Graphics Processing Unit. This is a highly specialized, heavy-lifting brain built entirely to process and render complex visuals. So from high-definition video editing to gaming, the GPU takes that highly specific visual burden entirely off the central manager's plate, which allows both processors to operate at peak efficiency.
Next, we move over to memory, specifically RAM versus ROM. And understanding the literal words here perfectly explains how a computer actually thinks. RAM is random access memory. Now, random access implies it's highly active, flexible, and temporary. It's the short-term working memory your computer is using right now for the applications you currently have open. It's constantly writing and rewriting data. ROM, however, is read-only memory. Read-only means it is fixed, it's permanent. It holds the fundamental, unchangeable instructions your computer relies on just to boot up. You can't easily overwrite it, which is exactly why your system remains stable every single time you hit the power button.
Now, when it comes to long-term storage, you'll see a clear evolution in technology sitting right there in the acronyms. HDD stands for hard disk drive. The keyword is disk. This is legacy tech that literally relies on a spinning magnetic platter and a little mechanical arm to read your files, kind of like a record player. Contrast that with today's modern standard, the SSD, or solid-state drive. Solid state means there are zero moving parts. It stores data electronically in microchips. Because we've completely removed the physical mechanical movement, the solid-state drive is drastically faster, entirely silent, and far less prone to physical failure if you happen to, say, drop your laptop.
Rounding out the physical hardware, we have some essential peripheral and display terms that allow those internal brains we just talked about to communicate with the outside world. First up is USB, the Universal Serial Bus. It was designed to be perfectly universal, standardizing connections so you could plug almost any peripheral into any machine without needing a dozen different custom cables. Then we have BIOS, your basic input-output system, which manages exactly that, the basic traffic of data coming in and going out, the very moment you start your system up. For displays, LCD is a liquid crystal display, which uses the physical properties of liquid crystals to modulate light and create an image. LED, on the other hand, is a light-emitting diode, relying instead on tiny electronic diodes to produce that image. So they both achieve a visual output, but through completely different physical mechanisms.
Okay, on to Section 3, networking and the internet, connecting to the world.
When we talk about networking, it is all about scale and geographical footprint. LAN stands for Local Area Network. This network is contained and local, like the closed private network linking the smart devices inside your house or the computers in a single office building. But to reach out globally and connect those isolated buildings together, you have to connect to a WAN, a wide area network.
The wide implies vast geographical distances. In fact, the global internet itself is literally just the ultimate, worldwide example of a wide area network.
Let's actually look at this as a step-by-step journey of connection. Step 1, you need a gateway just to access the infrastructure. That's your ISP, your internet service provider, the company granting you access to the network. Step 2, to actually communicate across that network, your data has to follow a strict set of global rules, so every single device understands each other. That is your IP, or Internet Protocol. Step 3, by strictly following that universal protocol, your device can successfully navigate to its destination, the WWW, the vast and interconnected World Wide Web.
So, once you're online, you're going to need tools for navigation and security. A URL is a uniform resource locator. It acts precisely as a locator to direct your browser to a specific file or page housed somewhere on a server. To translate human-readable domain names into the numerical IP addresses that machines actually use, we rely on DNS, the Domain Name System. It essentially functions as the Internet's automated lightning-fast phone book. For security, a VPN is a virtual private network, which creates an encrypted, private tunnel for your data to travel safely through public networks without being intercepted. And lastly, the everyday wireless standard we all use, Wi-Fi, simply stands for wireless fidelity.
Shifting gears now to Section 4, Software and Programming, the invisible instructions.
The absolute foundation of your digital environment is the OS, or operating system. It is the primary foundational software that manages all the physical hardware and all the other software applications on a computer. And the name is completely literal here. It is the overarching system that dictates exactly how your machine operates, allocating memory, processing power, and storage so that everything functions in total harmony. When your operating system takes you online, you interact with HTTP, the Hypertext Transfer Protocol. This dictates the rules for how web pages are actually transmitted to your screen. However, you really must pay close attention to HTTPS. That added S stands for secure. It means the data transfer between your browser and the website is fully encrypted. Seriously, whether you're entering a password, sending a private message, or typing in a credit card number, verifying that secure protocol is present is an absolutely mandatory digital habit.
Now, behind the scenes, we have the foundational languages that build our digital spaces. HTML is the hypertext markup language used to logically structure the content of web pages, while SQL is the structured query language used to efficiently manage and pull specific data from massive databases. Now, take a second and consider the word interface in our next two terms. An API is an application programming interface. This is a structured way for separate software applications to talk directly to each other and share data without any human input whatsoever. A GUI, however, is a graphical user interface. It relies on graphical visual elements like clickable buttons, windows, and menus. It's an interface designed specifically for a human user to seamlessly interact with the underlying complex code of the system.
We have to highlight one of the most ubiquitous files you'll ever encounter, the PDF, or Portable Document Format. The entire secret to its global success and massive universal adoption is right there in the word portable. It was specifically engineered from the ground up to retain its exact visual formatting, fonts, and layout no matter what device, operating system, or screen size you happen to open it on. It ensures that a document looks exactly the same to the sender as it does to the receiver. Moving into Section 5, Emerging Tech, the vocabulary of the future.
You have likely seen these immersive acronyms debated constantly as they push further into mainstream consumer electronics. AR versus VR. AR is augmented reality. In this setup, the real physical world remains entirely visible to you, but it's augmented or enhanced with digital data, graphics, or information layered seamlessly right over your field of view. VR is virtual reality. It requires a fully enclosed headset because the physical world is intentionally blocked out and replaced entirely by a simulated 360-degree virtual environment.
We are obviously living through the rapid rise of AI and ML right now. AI is artificial intelligence. That's the broad, overarching concept of creating machines and software capable of simulating human intelligence, reasoning, and decision-making. ML, or machine learning, is actually a subset of AI. It's the specific computational process of feeding vast amounts of data into a system so it can learn, recognize complex patterns, and independently improve its performance over time, all without requiring a human to write explicit programming for every single new task.
Finally, Section 6, Expanding Your Tech Vocabulary. Where to learn more. If you want to dive even deeper and master more complex jargon, our source material highlights two really excellent educational resources. Geeks for Geeks and the Testbook Portal both offer massive, comprehensive dictionaries of technological terms and computer awareness guides to help you continue your education. They are fantastic jumping-off points for anyone looking to build a much more granular understanding of the digital tools we use every day.
So as technology pushes forward at this blistering pace, what entirely new acronyms will emerge to define our future? The tech alphabet soup is only going to grow and evolve as new hardware architectures and software paradigms are invented. But by taking the time to understand the literal words behind the letters we currently use, you now have the foundational tools to crack the code of whatever comes next. Thanks so much for joining us for this explainer, and keep learning.